Hey everybody, in this video we're going to talk about applied calculus, and the example I want to use is a fever. So imagine you have a certain viral infection, and this viral infection, we don't know what it is, but we know that it causes a fever, and a fever is when your temperature is above normal, above the normal range, and this can cause muscle contractions and muscle aches. It can cause you to feel cold or give you the chills. And so imagine we have a model to express this fever duration and the intensity of that fever over some period of time. And let's say our model is capital F of x, and it equals, and by the way, this is just a generic model. This isn't based on any studies or data. Let's say it's negative 2/3 x squared plus 14 over 3 x plus 96. And now what do our variables represent? X is our days with which we've had the fever. X is days, and this is all measured in degrees Fahrenheit. So for anybody that uses centigrade, we are using Fahrenheit. Okay, so we have our model, and we are curious when the maximum temperature is reached. So the worst part of the fever. We want to know when that occurs. And so to do that, we can take the derivative of our model, and to do that we can say f of x prime is equal to 2 times 2 negative 4/3 x plus 14 over 3, and this is our derivative function. And so that's the rate of change, and by setting our new equation to 0, so 0 equals negative 4 over 3x plus 14 over 3, we can determine where the slope is 0. And if you recall, when the slope is 0, that's going to be a local min or a local max. So this would be a local max, this would be a local minimum point. So when the slope, which is this derivative function, is equal to 0, we know that's a maximum or minimum. To determine whether it's maximum or minimum, the leading coefficient, if it's negative, that means the next point will likely be downward sloping. So it's going to be, for our case, it's going to be a maximum. And so we set it equal to 0. Now we need to solve for x. And so we subtract 14 subtract 14 over 3, and we get out of room is what we get. Cool, I didn't know that square got larger. It's kind of cool. So we have negative 14 over 3 is equal to negative 4/3 x. And so we can divide by negative 4/3, which is the same as multiplying this by negative 3/4. And so we get 3 times 14, which is 42, and this is going to be a positive number. 42 over 12 equals x. And This goes into this roughly 3 point something. So this is roughly 336, 3.5 maybe? 3.5. 36 plus 6 is 42. Yeah, 3.5 is 3.5 days. So at 3.5 at 3.5 days, we are at the peak temperature from our fever, from our viral infection. And so if we plug in our 3.5 into the original equation, we can determine what that temperature is, in fact. And so we get f of 3.5 is equal to negative 2 over 3 times 3.5 squared plus 14 over 3x, not x, 14 over 3 times 3.5 and plus 96. And what does this equal? I will pause this and calculate it for you because I don't know. And so after plugging that in, this is equal to roughly 104.2 degrees Fahrenheit, which is our maximum, our local maximum. And so if we expressed our domain earlier, we see that from day 1 of our viral infection, where x is greater than or equal to, let's say, over 6 days, at day 3, the temperature will reach a maximum of 104.2 degrees Fahrenheit in the patient. And there you go, a little bit of applied calculus. And with that, we'll see you in the next video.